Today we are doing sections 10.1 and 10.2. We are starting them today. We'll work on them more tomorrow. Our objective is to review the concept of order, to graph inequalities in one variable. In order to warm up, we are going to classify these statements as true or false. It might help if we remember that this symbol is read as greater than, and this symbol is read as less than. So the first statement says 7 is greater than 6. True or false? Everybody should be able to say it all at the same time. True. 7 is greater than 6. Number 2 says 6 is less than 6. False. And the last one, before we evaluate it, we need to evaluate their absolute values. So what is the absolute value of negative 1? 1 is less than, what's the absolute value of negative 9? 9. Once we do the absolute values, it says 1 is less than 9.
True.
That's true. A number line shows order relationships among real numbers. Like we just went over, this first inequality symbol is greater than, the second one is less than. One way that might help to remember it is that the less than symbol, the arrow is pointing left. Or if we were to open this symbol up, we could kind of make an L out of it if we were to open it up. Just to review a number line real quick, I don't think this is in your notes, but what number do we always have to have on a number line? 0. It does not always have to be in the middle. A lot of the times we like it to be in the middle. And if I start putting numbers to the right of 0, what kind of numbers are those? Positive numbers. If I put numbers to the left of 0, what kind of numbers? Negative. And which negative number is closest to 0 if I'm doing integers? Negative 1. Okay, I see all sorts of strange things when people make their own number lines. This is how it should look. On our first couple examples, we need to translate the following sentences into symbols. The good thing about these is that usually they go in order. At least they're going to start us off that way. So example 1 says y is greater than or equal to negative 5. So I'm just going to go in order. Y is greater than or equal to. So we've already talked about the greater than symbol being this inequality. How do I put the or equal to part? Put a line under it. If we put a line under the inequality symbol, that means or equal to. Negative 5 goes on the other side. Y is greater than or equal to negative 5. Example 2, x is less than, so remember less than points to the left. Less than or equal to, so again it needs the bar, 8. This goes back to what we were doing with the notes. Who can raise their hand and tell me how we would read this top one? For example 3. Keon. Very good. Negative 6 is greater than or equal to 3. What do we think about that one? True or false? Why is that one false? Because the 6 is negative. A negative number is never going to be greater than a positive number. Does anyone else want to volunteer to read a statement before I start pulling popsicle sticks? Connie, can you read number 4?
23 is greater than or equal to 17.
That's one way of reading it. What's the way of reading it the way it's written, Ellie?
17 is less than or equal to 23.
Good. If you reverse it, technically it's correct. The way that it's written is with a less than symbol, but you can flip the whole thing around. And it means the same thing. Either way we read it, what do we think? True or false? True. Any volunteers for example 5? Deja? Good. Negative 10 is less than or equal to negative 15. True or false? False. Good. If you have to put it on a number line, do that. When they're both negative numbers, sometimes it's hard to tell. All right, the last one. We've got 2 inequality symbols all in one sentence. Any volunteers for that one? Any new volunteers for that one? Lexi?
3 is greater than 0, greater than -5.
Very good. 3 is greater than 0 is greater than -5. What do we think? True. Both parts of that are true. 3 is greater than 0 and 0 is greater than -5. When it comes to graphing these, we have to remember that we would use an open circle on our graph if we have a plain less than or a plain greater than symbol. And we would use a closed circle on our graph if they have the equal to bar underneath them. When we're graphing, the variable should always be on the left. Now that's not necessarily a strict requirement for algebra, it just makes it easier for us if your variable is on the left. When multiplying or dividing by a negative, we have to reverse the inequality symbol. What that means is that we flip it over. Alright, so we are going to work on graphing these on number lines. You should have number lines there on your page already. We're just going to have to label them. So for the first one, I know I need 0 on there somewhere, and my number is positive, so I'm going to choose to put 0 a little bit closer to the left, which gives me plenty of room to count up to 3. So then I have to decide, do I want an open or closed circle at 3? Jamal, what do you think?
Open.
Open, why?
Because it's not greater than or equal to, less than or equal to.
Good, we don't have the equal to bar, so it's going to be open. And then we have to decide on these which way we're going to shade. So that can be the tricky part. Who can read this statement to me? Keon. X is greater than 3. So do you think we need numbers that are to the left or to the right? To the right. The numbers that are greater than 3 are going to be the numbers to the right. So we are going to shade to the right, including the arrow. Shade the whole thing in. A couple of notes I'm going to make about all of this. Alright, number 8. I know I need a number line. I know I need to get all the way to -5. So I'm going to place my 0 closer to the right side so that I can count down my negative side to -5. All right, any volunteers to read the statement on number 8? People I have not heard from yet today. Ryan?
Just read the negative 5 is less than x. So
Less than or
or less than or greater than 2x.
close.
Less than or equal to.
Very good. So negative 5 is less than or equal to x. So if we wanted to flip that statement around, it'll make more sense to us. But if we flip it around, the whole thing gets flipped around. So the x goes to the other side, the inequality flips over, the negative 5 goes from the left side to the right side. So we would flip the entire thing over. So instead of it saying negative 5 is less than or equal to x, what would this one read? Okay, we need hands. So I'm hearing from the same people. Shannon, what do you think?
X is greater than or equal to negative 5.
Wonderful. So that's what we're going to graph. Houston, do I want an open circle or a closed circle? Closed. We have an equal to bar on it. It's going to be closed. Again, make an appropriate sized point or circle. Why is it closed? Ellie? Alright, so we flipped it over so that we could read it as x is greater than or equal to negative 5. Flipped it over. Decided we needed a closed circle because of the equal to bar on our inequality symbol. Now the last thing we have to do is decide which way we're going to shade it. We have to decide if we're going to shade to the left or to the right. Carl, what do you think? So shading to the left means I'm going to be picking smaller numbers for x. But this says x should be greater than or equal to negative 5. Good, so we will shade it to the right if we want bigger numbers. If we want x to be greater than negative 5, that means we want numbers bigger than negative 5. Those numbers are found on the right side. Now, as long as our variable is on the left, this only works if the variable is on the left, we can look at the inequality symbol and look at which way it points. Greater than symbols point to the right, and we shaded the right side. When we see examples with less than symbols, they point to the left, and we will shade to the left if it is less than. Alright, on to examples 9 and 10. These are what we call compound inequalities or a double inequality. So again, we make a number line, making sure we've got enough space for both of those numbers. This time I'm going to put 0 pretty close to the middle, because I need to get all the way up to a positive 3, but I also need to go down to a negative 2. Kyan, can you read that statement on number 9?
Negative 2 less than 3. Less than or equal to 3.
Very good. Negative 2 is less than m is less than or equal to 3. So we are going to put points at both of these numbers. At negative 2, Natalie, should we put an open or closed circle?
Open.
Very good. At negative 2, we put an open circle. Logan, what about at 3? Should we put an open or closed circle at 3? Closed. If it's got the bar on it, it needs to be a closed circle. So the shading part on these, it's tricky if you're trying to apply the same rules that we used before. But one way that we could describe this, just looking at this, is that m is in between -2 and 3. So the letter m is physically sitting in between this -2 and this 3. So we are going to shade in between those 2 points. So if you have a double inequality where the variable is in between two numbers, you're going to shade in between those two numbers. Now on any of these, you could check if it's true or false by picking a number that you shaded. What's a number that we shaded in? 0. Pick one that's in between. So yeah, we colored in at 3, so technically you could use that. I prefer to use one that's in the middle somewhere of where we shaded. So I would use a number like 0. If you plug 0 into m, decide if you get a statement that's true or false. So we have to decide -2 is less than 0. 0 is less than or equal to 3. Are both of those statements true? Is -2 less than 0? Yep. Is 0 less than or equal to 3? Yep. So that works, so we must have shaded the right spot. So if you're ever unsure about your shading, that's how you can check. Also, that's why we didn't shade outside on either side of these. Because if we were to pick a number bigger than 3, it's not going to be less than or equal to 3. Okay, so that's why only the numbers in between those are going to work. Alright, let's try another one that is similar. Again, I'm going to put 0 pretty close to the middle so that I've got enough room for my numbers. I have to decide open or closed circles. Connie, at -3, should it be open or closed? At -3? Closed, because we've got that equal to bar. If it's got the equal to bar, it's closed. Good, we want an open point at +2. There is not an equal to bar on it. Tariana, where should I shade? In the middle, in between those 2 points. If x is in between -3 and 2, that's where I'm shading. Alright, the next type of problem we're going to do would be to solve the inequality and then graph its solution set. We are going to solve inequalities much like we would solve equations. The only difference is that we've got to worry about this symbol, and then we are going to graph our answer on a number line. Alright, we are going to solve these much like we did equations. That means I am going to box in my variable and split up my problem. I want to get x alone. May, what am I going to do to get x by itself? Very good. We add 7 to both sides. That gives us x is less than or equal to 16. Sorry, 23. On this problem, when I make my number line, I am not going to count all the way up to 23. That is just unnecessary. I do know that I want it to be positive. So I am going to put my 0 towards the left side. And then I get to pick what increments I count by. But they have to be even increments. Okay, so we're not just going to plop a 23 on there wherever we feel like it. We got to count by something. We've counted by 1s. That's going to be kind of obnoxious. Does anybody else have a number they'd like to count by? Keon? Sure, we could count by threes if we wanted to. So 3, 6, 9, 12, 15, 18, 21, 24. Counted by threes. What number is it that we're trying to put on this number line? 23. Roundabout, where's that going to go? Between 21 and 24, probably a little bit closer to what? 24. Is it going to be open or closed? Closed. We still have to decide where to shade. If we read this out loud, it says x is less than or equal to 23. So am I going to shade to the left or to the right? Left. Less than. We shade to the left. All right, on number 12, we need to get x by itself first. Jeriel, how are we going to get x by itself? How do we undo subtraction, Jeriel? I'm sorry? We add 10 to both sides. Negative 10 plus 10 is 0. We have 0. That's a greater than symbol, x. But my variable is on the right, and I don't want my variable on the right. I want it on the left. So I'm going to flip the entire thing over. So I'm going to flip the entire thing around. So I'm going to put my x on the left side. I'm going to flip my inequality symbol. I'm going to put 0 on the other side. Now I'm ready for a number line. I need to put a point at 0, so it doesn't really matter where I put 0 or what I put around it. Adrian, do I want an open or closed circle at 0? Open circle at 0. Jaquan, which way do I want to shade? If our variable is on the left and we have a less than symbol, that means we're shading to the left. All right, this rule is a reminder of one that we already filled in our notes earlier. When multiplying or dividing by a negative, we have to flip the inequality symbol. So that only happens if we're multiplying or dividing both sides by a negative. On number 13, we're trying to get the variable by itself. In order to do that, Kelby, what will I do to both sides? Multiply it by 3. Did I multiply both sides by a negative? No. So I do not need to flip my inequality symbol at this step. What is 3 times negative 6? Negative 18. So just because there's a negative involved does not mean that I have to flip this symbol around right now. Now when I go to rewrite it to get my variable on the left, that will make it look like I'm flipping it, but I'm moving the whole problem around, not just my inequality symbol. Okay. We make a number line. We've got a negative number, so I'm going to put 0 pretty close to the right-hand side. Now I have to decide something to count by. Sure. You can count by whatever you want to. 3s, 4s. Personally, I didn't make a very big number line. I'm going to count by 6s. You can count by whatever you want to as long as it's consistent and you put your point in the right place. Now I need to put my point at negative 18, but I need to know, Jalen, is it open or closed? I'm sorry? Open, very good. When I rewrote this with my variable on the left, how would I read that? Deja. Good. S is less than negative 18. So Danielle, which way should I shade? To the left. On to number 14. I'm trying to get P by itself. Ellie, what should I do to both sides? Multiply by negative 13. Did I multiply both sides by a negative? Mm-hmm. Yes. So that means that my inequality symbol has to flip right now. So now instead of a less than symbol, it flips over to be a greater than symbol. If you multiply or divide both sides by a negative, the inequality symbol flips. Over here I've got negative 3 times negative 13. A positive 39. Alright, we're ready to graph it. Our variable's on the left, so we don't have to worry about flipping it around again. I've got a positive number, so I'm going to put 0 towards the left side of my number line. I have to choose something to count by. I like the idea of counting by tens also. Alright, I count by tens, but I got to decide where that point is going to go. Who can raise their hand and tell me where they think I should put it? Lexi. Close to what?
Close to 40.
Close to 40, but should it be on the left or the right?
Right. Wait, left.
The left. Okay, so we're close to 40, but we're not past 40. Open or close circle? Open. Delaney, which way should I shade? How would we read? Okay, so once we flip our inequality symbol around, we would read this as P is greater than 39. So it'd be to the right. We want bigger numbers. I'm trying to get N by itself. Who can tell me what to do on both sides? Jaquan. Subtract 9. Jaquan, if I subtract 9 from 13, what do I get? Thank you. Is my variable on the correct side? No. So I'm going to take this whole thing and flip it all over. Once I flip the whole thing over, Lexi, how would that read out loud? N is less than 4. Alright, so I make my number line. I'm fine with counting by ones on this. I know I need a point at 4. Jakeem, is it going to be open or closed?
Close.
What makes you say that? It does not have the equal to bar on it, so therefore it is open. And actually at this point it's not greater than anymore, it's less than. But either way, we should know that it's open the whole problem. Lexi already told us that we would read this as N is less than 4. Jamaro, how would we shade it? To the left or to the right? To the left. If it is less than, we shade to the left. All right, we've got to get x by itself again. Keon, how do we get x by itself here? Divide both sides by 3. Do we need to flip our inequality symbol? No. We did not divide by a negative, so we can leave it alone. 57 divided by 3. 19. We got to make a number line. We got to choose what to count by. 5s. Works for me. All right. Ryan, do I want an open or closed circle at 19?
Open.
Open. Where is 19 going to be?
Just before 20.
Good. Just before 20. And which way am I shading?
Right.
To the right. Greater than, we shade to the right. I won't finish it. So to start off 17, I need to get n by itself. What do I need to do to both sides? If I divide by negative, what special thing happens? We flip the sign in the middle here. What is negative 108 divided by negative 18? A positive 6. But is my variable on the side that I want it on? No. So now I'm going to flip the whole thing over. So my sign flipped 2 times for 2 different reasons. That's all I wanted to talk about with 17. On 18, what would we have to do to get b by itself? Subtract 19. So from there, you should be able to finish that problem on your own.